All right, so this is my circuit that I made for my robot, and I decided to do the countertop cleaner robot. It turned out to be a little bit more complicated to make than I thought it would be, because as it turns out, there's a lot that goes into mapping an environment and making sure that your robot doesn't fall off a counter and moving it around and recognizing the edges. So I had to um, take some shortcuts and include some sensors and as to sort of simulate commands from a more advanced program that would map an environment and actually create a path for the robot to follow. So in this, I have the auxiliary controls, which would be things like the wheel hubs, which are these two hobbyist motors um, that would spin the back and the forward wheels, and then this servo here, which would act as the steering mechanism, which would be mechanically tied into one of these, either the front or the back, to turn the wheels, and that gets its command from this photoresistor, which could be as just kind of a representation for more advanced analog commands that would tell the robot how much to turn based on an analog input. And then as far as edge detection goes, I'm using a distance sensor. And this is just an easy way to demonstrate that the robot knows about how wide it is, which is approximately 8 inches. And so anything approaching within that 8 inches will cause the wheels to back up and would then obviously be tied into like a turning command for the servo. But again, that would rely on some 3D mapping of an environment, and I definitely can't do that. So I'm just kind of using this as a rough estimation as to what that would look like. And these two DC motors down here are both for the cleaning apparatus. This one is for spinning the cleaning brush at a constant speed while it's in operation. So this is after it's mapped its environment and it's already started moving. And then this other one intermittently spins at a much lower speed to pump cleaning solution onto the brush while it's in operation. So that's been slowed down and put on a delay. So if you see, I'll switch to the code and start it up. I had to wire in an extra 9-volt battery for all of the motors, but this would be rechargeable, obviously, once it was all built in. So once it starts, you would imagine that this photoresistor input is set at neutral. And again, we're kind of taking a lot for granted, just starting it like this, but there would be an advanced mapping program that is checking the environment and coming up with some sort of route for this robot to take. And the sensors along the outside edge of it would be able to track where it is alongside. So we're pretending that all that exists, and I wrote that, and it's definitely real, and it's all right here. But it's going to be represented by this photoresistor and this distance sensor. So it is running, and this is our neutral. And as you can see, it's in forward because it's being told it's not up against the wall, and it's going straight because this is a neutral. But if you decrease photoresistor enough, it will turn. And as the signal changes, so will the orientation, and it turns to the right. But if you go the other way, it turns to the left. That's pretty easy. And then this, it's a little bit wonky, just because because the robot is small. The distance sensor's range is a little bit longer than what I'd need it to be. But if you watch these hobbyist motors down here, as the distance shrinks, then these will slow down and go in reverse. But as soon as it's good to go, they ramp back up in speed. And if you look at this, you just have to assume again that the program is running and it's moving along. This is the brush motor. This is for the pump. And that's pretty much all there is to it. You can change this to change direction, and this to change speed and the orientation. And then all the code will be linked alongside, so you can look at this or pause it and watch what it's doing. But that's it.